and we will try to understand how this algorithm is working step by step with numerical example. Topics covered in this video. First, we will start with basic introduction, inspiration, different mathematical models used in this algorithm, grasshopper optimization algorithm steps, and we will try to understand its working with the help of a numerical example. And in the end, we have advantages and disadvantages for this algorithm. This is the conclusion for this video. You can see we computed the values up to 9 iteration, and after that we obtain the best solution. Let's start with introduction. As we all know, grasshopper are the insects and they live in nature, and they also affect and damage crop production. As you can see the green grasshopper in the image, hope you can detect. They are very hard to detect. As you can see here, the grass color is also green, and the green grasshopper, hope you can see here. You can see we have similar colors, so they are very hard to detect in the nature, especially the green grasshopper. This is grasshopper life cycle. First we have eggs, from eggs nymph, and here we have different nymph stages, and in this stage grasshopper has no wings. As you can see, this is nymph and no wings, you can see here, and you can see this is an adult grasshopper, and you can see the wings here. In the nymph phase, they can make only small steps in movement, and as in the adult stage, they have wings. They can make sudden jump and they can cover long range as compared to nymph. Grasshopper optimization algorithm is inspired by the foraging and swarming behavior of the grasshopper in the nature. And this algorithm is basically inspired by the long range and movement of the adult grasshopper in the nature. As you can see the difference, this is an adult grasshopper and this is nymph. And this algorithm is inspired by the long range and sudden movement of the adult grasshopper. As you can see, grasshopper live in nature, so this is nature inspired algorithm, and this is inspired by the foraging and swarming behavior of the grasshopper. So this is a swarm based algorithm. We have two categories for the meta heuristic algorithm: single based and population based. As here we are talking about the swarm, so this is a population based meta heuristic algorithm inspired by the nature. In the nature again we have different types, so here we have swarm. So this is a nature inspired meta heuristic algorithm. In the meta heuristic algorithm, search process is divided into two phases: exploration phase and exploitation phase. This is the mathematical model that we can use to represent the grasshopper behavior. Here xi, you can see I means the ith position of the grasshopper. In the value for I is 1 to n. This n is the population size, and Si represents the social interaction in the group, and this is the force of gravity, and here this is the wind direction. Grasshopper are the only living creature that form largest swarm, and here food source foraging is important behavior of the grasshopper swarm, and they are looking for the different food sources. So this is the important behavior of the grasshopper. In the meta heuristic algorithm, as we already discussed, search process is divided into two phases: exploration phase and exploitation phase. So in this algorithm, exploration phase contain sudden movement and jump, and exploitation phase contain local movement to search for better food sources. So in exploration phase, we will search for the food sources. So here we will update all the values position for the grasshopper and we will compute the fitness values. In the exploitation phase, we will find out the best solution among all. That is the target. As you can see, this is the mathematical model for the grasshopper behavior. Grasshopper can jump and they can make sudden moves. So for this behavior, we used random values. So for grasshopper random behavior, we use the random values in the range 0 and 1. So here R1, R2, R3 are the normally distributed random values that are used for the grasshopper random behavior. As in the nature, they can easily make sudden jump or move, but in this algorithm, we will use random values for the random movement. Now we have this mathematical model. We need to compute value for SI, GI, and AI. So how to compute the social interaction in the grasshopper group using this equation? Here S is the social force and we can compute this using this equation. Here Dij is the distance between ith and jth grasshopper. As you can see, this is the distance between two grasshopper and this is the unit vector. And please note that value of j is not equal to I, as we are going to compute the distance between ith and the jth grasshopper. So value for I and j are not equal, so we need different values. After that, we can compute the force of gravity using this equation. This is gravitational constant and this is the unit vector toward the center of the earth, and the wind direction can be computed using this. This is the drift constant and this is the unit vector in the wind direction. After that, you can see we will replace all the values. Here you can see the values for SI, GI and AI, and you can see the value for Dij is this one, value for this one is this one. So let's replace all these value and you can see after this we got this equation, but we cannot apply this equation directly to solve any optimization problem. Why? Because when you will use this equation directly to solve optimization problem, there is no convert to target location and grasshopper reach quickly to the comfort zone. So instead of this equation, we will use modified version of this equation, that is this one. Here gravity is 0 and instead of wind direction, you can see we use best solution found in the current population, and value for C can be computed using this equation. Here you can see upper bound, lower bound, and this is the distance between two grasshopper. Now this is the main algorithm for this. So we have certain steps that we will follow for this algorithm. First, we will initialize all the important parameters. Then we will initialize the population randomly. In step 3, using a fitness function, we will compute the fitness value for each grasshopper in the population. After that, we will select the best solution among all, and then we will check this condition whether current iteration is less than maximum iteration or not. If this condition is true, then we will move to the next step, else we will print the best solution and stop. In step 6, we will normalize the distance between grasshopper. After that, we will update the position for the current grasshopper, and then we will check if there is any grasshopper outside boundary or not. And then we will update the current best solution if there is any new best solution found or not. if there is any new batch solution, then we will replace the current batch with the new batch solution. And then we will increment the counter. If condition is true, then move to this step, else return the batch solution. Now let's try to understand this working with numerical example. First, we will initialize all the important parameters. Here, maximum iteration we are using 9. This is value for C minimum, C maximum. Lower bound is -5, upper bound is 5, dimension is 2. Here you can see initial population size is 4. So we will use 4 grasshopper. You can see value for I is now 1 to 4, as we have 4 grasshopper in the current population. And you can see here we have dimension is 2, 1, 2. Now using a fitness function, we will compute the fitness value for each grasshopper in the current population. So this is the cost function that we are using here to compute the fitness value for each grasshopper. Here you can see we have x1 and x2. So in the current population, you can see these values for x1, values for x2. Now, using this fitness function, we computed all the values for the current population. Now, we will select the best solution among all. So we will consider the minimum value as the best solution among all. And this is the minimum value you can see among all. So we will consider this best solution. After that, you can see we got the position and the fitness value for the best solution. In step 5, check while the current iteration is less than or greater than maximum of iteration or not. So we will check this condition. As in the first iteration, we computed the fitness value for the initial population. So now we will start with iteration 2. Now check this condition. Here 2 is less than 9. So condition is true. So we will move to the next step. If this condition is not true, then stop and display the best solution. Right now you can see we are here. So we will check this condition. If this condition is true, we will update the values for C1 and C2. Then we will start the for loop. So right now this condition is true. Now we are here inside for loop. Now in step 6, we will normalize the distance between the grasshopper. So now we will compute the values for this equation. After calculation, we got the values for this equation. Now in step 7, we will update the position for each grasshopper. And how we can update the grasshopper position using this equation for the each grasshopper in the current population. So we can update the position for any grasshopper based on the basis of their current position, best solution found, and the position of other grasshopper. Now here, as we already computed values for this plus best solution, that we got this one and we got this. So this is the new position for each grasshopper, as you can see. So for each grasshopper one by one, we will compute the values, and this is the new position for each grasshopper in the current population. Now we are here, as you can see, inside for loop. Here we updated the position now for each grasshopper. So this is new position. Now we will check the grasshopper boundaries. Now we will bring the grasshopper back if it goes outside boundaries. Now boundary means here lower bound and the upper bound, that is the domain. So we need all the values within the domain, that is here in between this and this. So we need all the values in between the domain, and you can see all the grasshopper are within the boundary. So do not think. In the next step, for new population, we will compute the fitness value for the each grasshopper using a fitness function. So for each grasshopper, you can see the new fitness values are computed as this. Now we will update the current best solution. So here you can see this is the older best solution. Now we are going to update the current best solution if there is any other best solution or not. So how we can do that? We can compare the new and the old fitness value for each grasshopper. So here you can see this is the best solution that we found. Now we will compare this old fitness value with the new fitness value that we computed smaller. And you can see among all, this one is the minimum value. So we will consider this one as the new solution now. So we will replace current best solution with this value. So now our new best solution is this one, and this is the position. Now we are here, update the best solution. We updated the best solution now. Now we will increment the counter, and when you will increment the counter, it will check the condition. If condition is true, then again we will go inside this loop, else we will return the best solution. Done. As you can see, if this condition is true, again we will move inside this loop, and again we will compute all the values. If this condition is not true, we will print the best solution that we computed here, that is this one. As you can see, we computed the values up to 9 iteration. Here you can see for this, current iteration is 2 and maximum of iteration is 9. And we got best solution, this one, that is this one. Now we incremented the counter, value is 3 and 3 is less than 9. So condition is true and we got new best solution, this one. Now increment the counter, condition is true and we got best value, this one. Again increment the counter, condition is true and this one is the new best solution. Increment the counter, 6 is less than 9 and this is the new best solution. Again increment the counter, now current iteration is 7 and 7 is less than 9 and this is the new solution. Increment the counter, current iteration is now 8, 8 is less than 9, condition is true and this is new best solution. Again increment the counter, now value for the current iteration is 9 and the maximum of iteration 9, so condition false. So we will print the best solution as this one. Advantages: Grasshopper optimization algorithm provide high accuracy and we can obtain good solution. And disadvantage is it can easily fall into local optimum. So as you can see, that's all about this algorithm. First we will initialize all the important parameters. After that we will initialize the population randomly, then compute the fitness value for each grasshopper in the current population, select the best among all, then check this condition whether current iteration is less than or greater than maximum of iteration or not. If this condition is true, then move to next step, else return the best solution that you computed here. Now if this condition is true, normalize the distance between the grasshopper, update the position for the current grasshopper, check the boundary, and in the end we will update the current best solution. Increment the counter. When you will increment the counter, it will check whether condition is true or not. If condition is true, again repeat this loop, else if this condition is false, like this, here you can see condition is false, then return the best solution that you found in the previous iteration. So that's all about this video. If you have any question, you can comment below, and thanks for watching this video.
Looking for a simple yet secure way to manage employee email signatures? Discover Let's Sign It, the best solution